Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. We have been doing electronic displacements in our previous two videos, and we have covered inductive effect, electromeric effect, resonance or mesomeric effect. In this video, we'll be covering hyperconjugation effect or no bond resonance or Baker-Nathan effect. So, in the study of inductive effect, we have seen that alkyl group has a plus I effect, that is electron repelling effect, and the order of this electron releasing effect of different groups is methyl is less than ethyl is less than isopropyl is less than tertiary butyl group. But when the alkyl group is, these alkyl groups are attached to an unsaturated system such as a double bond CH double bond CH2 group, the order of inductive effect gets reversed. This behavior of alkyl group is explained with the help of hyperconjugation effect, and since it was noticed for the first time by Baker and Nathan, it is also called Baker and Nathan effect. So when this methyl group is attached to this unsaturated group, the pi bond electrons, they will pull the electrons of carbon hydrogen sigma bonds towards itself. So these electrons move here. As a result, a negative charge comes on this carbon atom, whereas the positive charge comes on this hydrogen atom as the electrons have moved away and a double bond is formed here. Similarly, the electrons of this alpha carbon hydrogen bond may also be involved in conjugation or of this carbon hydrogen bond. So these different structures show hyperconjugation. Pi electron pair of double bond causes the cleavage of carbon hydrogen bond of the methyl group, and electron pair of the bond conjugate with the pi electron pair of the double bond. As there is no actual bond between the alpha carbon and the hydrogen ion, this hyperconjugation is also called no bond resonance. It is quite obvious that greater the number of alpha hydrogen atoms, more will be the electron releasing tendency of alkyl group. Methyl group attached to this double bonded carbon atom. Now the next carbon next to double bonded carbon atom is alpha. So there are 3 alpha hydrogens. Whereas in ethyl, CH3, CH2 and CH double bond CH2, there will be only 2 alpha hydrogens. So in methyl there are 3, in ethyl 2, in isopropyl 1, and in tertiary butyl no alpha hydrogen. So the hyperconjugation will be more in methyl, less in ethyl, still less in isopropyl, and least in tertiary butyl group. In order that an organic compound may exhibit hyperconjugation, it must have at least 1 alpha hydrogen atom in conjugation with unsaturated system. Hyperconjugation is also known as no bond resonance. So we can study hyperconjugation from the orbital concept also. This orbital contains sigma electron bonding pair between carbon and hydrogen atom. Now in hyperconjugation, this sigma electron pair is in conjugation with the pi electron pair of the double bond. The electron pair of carbon hydrogen sigma bond is involved in conjugation with the pi electrons of the double bond. Thus hyperconjugation is a sigma pi bond conjugation. Though the proton of methyl group is not forming any real bond with the double bonded carbon atom, at the same time it is not in a position to leave its position. This hydrogen cannot leave the position even though it's not bonded here, but the electrons hold it together in the structure. Significance of hyperconjugation effect. Hyperconjugation effect is useful in explaining certain characteristics of the organic compound, ortho and para directing nature of alkyl group. Because of hyperconjugation, the pi electron pair will pull the electrons of the sigma bond between carbon and hydrogen and will get involved in conjugation. So double bond comes here and these electrons come here as negative charge. In the next structure, electron move to the next bond and the electrons of double bond come to this carbon atom, causing a negative charge over here. In the next structure, this negative charge comes and resides here as double bond, whereas the next bond is moved to the next carbon atom. In next structure, the electron of this charge will move to form a bond, double bond here, whereas the electrons move back to their position. So there are 5 hyperconjugating structures of. Now, similarly, these electrons may also cause hyperconjugation and these electrons may also cause hyperconjugation. But what we see is that as a result of hyperconjugation, negative charge comes either at the ortho position or at the para position or back at the ortho position. So the substitution that takes place is electrophilic in nature, that is a positively charged species such as chloronium ion will be resulting in substitution. So positively charged will get attracted to a negative charge which is at ortho or para or ortho position. So the alkyl group causes substitution to occur at ortho para position. So alkyl groups are ortho para directing in nature. This can be proved by hyperconjugation. Then shortening of carbon-carbon bond adjacent to multiple bond. We have seen that in this case there is a double bond involved here due to hyperconjugation. So this bond, instead of its regular bond length 154 picometer, it shortens in nature, showing a bond length of 149 picometer, which is because of hyperconjugation. Relative stability of alkenes. We see that a more substituted double bonded compound, and this compound has 12 alpha carbon atoms, will be more stable, whereas this compound with one alkyl methyl group less has 9 alpha hydrogens, so it will be less stable than this. This has 6 alpha hydrogens, this has 3 alpha hydrogen, no alpha hydrogen. This will be the least stable. So the more substituted a double bond, the more stable the alkene is. So that's all in today's video. Thank you. Have a nice day.